Here is the part 2 of the quadratic applications worksheet. We're now going to look at the guided practice problems off of the notes page that you've already received in class, or you can print out another copy on the LMS calendar. But we're going to look at the max and min problems. There's just a few of them, and let's get to it. Okay, so number 5, we are going to find two real numbers whose difference is 64 and whose product is a minimum. So we want to have a description of these two numbers that are unknowns, but we don't want to call them x and y. Instead, we want to choose a way to label it where we are staying in terms of the same variable. So for example, if we have x is our first number, we know that the difference is 64. So these two things are 64 units apart. So if one of them is x, then I either need to add 64 to get to the next one, or I need to subtract 64 to get to the other number. So I'm just going to go with x minus 64. Even if you chose x plus 64, it would still work. You could try it if you want. So here are the two numbers. So I've got one number, and the other one is 64 units away from it. So I'm going to call the first number x, and the second one x minus 64. The product is a minimum. Well, that minimum tells us that we need to be looking at a quadratic somewhere. So if we have these two numbers, and we multiply them together to get the product, I'll just call it P for a second, even though we don't really need to label it. But the product will be x is the first number times our second number is x minus 64. So their product should be a minimum. So if I distribute this x, I'll have x squared minus 64x. So now I have this quadratic that I can find the vertex of, because the minimum is telling us that we need to look at the vertex. So for this, if I'm looking for the x value of x, that would result in a minimum value p for the y value of the vertex. That product will be the minimum, but we need the x value. So x will be equal to negative b over 2a. That's the formula we use to get the x value of the vertex. So here, b is negative 64, but negative of negative 64 is positive 64. So it's 64 over 2 times a, which is 1. So 64 divided by 2 is 32. So I've just found out that x is equal to 32. So if x is equal to 32, then 32 minus 64 is negative 32. So my two numbers are 32 and negative 32. I don't actually need to find the product because I was just looking for the two real numbers. But in case you were curious, if I were to plug these back into my product formula that we've created, you would get a negative 1024 as your minimum product, just for extra information. Okay, let's look at the next one. So let's find two real numbers whose sum is 16 and whose product is a maximum. So this problem is really similar. So let's see, we have a number x, and we know that between the two numbers the sum is 16. So if I have 16 and I subtract the other number, that should give me two numbers that add together to be 16. Okay, so I have a product that is a maximum that I'm looking for. So if I have my product is x times 16 minus x, and multiply that out, I'll get 16x minus x squared. In other words, negative x squared plus 16x. So this, just thinking about this graph, there's a negative in the front, so it would open downward. And that's great because we are looking for a maximum product, so this works out. We will have a maximum on this graph. But really we do the same process as before. The x value of the vertex will be at negative b over 2a. The y value would be the maximum product. But we need the x value, so negative b, so negative 16 over 2 times a, which is negative 1. So negative 16 divided by negative 2 is 8. So now I know that x is 8. So x is 8. So then 16 minus x, which is 8, is also 8. So the two numbers that we needed were 8 and 8. Okay. Number 7. Fred has 400 yards of fence to make a rectangular corral. If a river will be used as one side of the corral, what should the dimensions of the corral be so that it has a maximum area? Let's draw a picture. So, here we go. Here's some water. It's a lovely river, isn't it? It's beautiful. So there's the river. And it's a rectangular corral. So let's do it in red. He has a red fence. Okay. So if the river is one side of it, then we have 3 other sides for the corral. Now if I had drawn this really well, the length of the opposite sides would be equal, which is really what we want. Since it's rectangular, opposite sides are equal. So if this side is x, I'm just going to call it x, and this one is x, because their opposite sides are equal, then how much goes on this third side? Well, if I have 400 yards of fence total, and I've already used up 2x, so I have 400 minus 2x. The length of this side is 400 minus 2x. So we're wanting a maximum area. Well, area is length times width, so let's multiply the sides together. So we have 400x minus 2x squared. Rearrange it a little bit. That area is going to be negative 2x squared plus 400x. Okay, so we're wanting a maximum area, but we need to find out what x is so we can write down the dimensions. So, looking at the maximum, that means we need to look at the vertex. So if x is the x value at the vertex, being negative b over 2a, let's plug in what we know. So we have negative b, so negative 400 over 2 times a, which here is negative 2. So negative 400 divided by negative 4 is positive 100. So we know that x is 100. So if we plug that back in for the other side, 400 minus 2 times 100. 400 minus 200 is 200. So this corral should be 100 by 200 yards for maximum area. Number 8. Find the dimensions and maximum area of a rectangle if its perimeter is 40 centimeters. Not a problem. So let's go ahead and do that now. Let's draw a picture. There's a semi-good rectangle. Okay, and we're looking for the dimensions and the maximum area, but we only know that the perimeter is 40 centimeters. So again, pick a side and call it x. So if that side is x, then so is this one, since rectangles have opposite sides equal to each other. We know that there is a perimeter of 40 centimeters, so all the way around there's 40. So if we're trying to figure out what's left for these two sides, we have 40, we've used up 2x already, but we have to split that between the two sides. So if we divide it by 2, we'll get 20 minus x. So that means for the other two sides, we can label those 20 minus x. So we're looking for the dimensions that give us a maximum area. So area is length times width. So let's multiply the sides together. So we get 20x minus x squared. Rearrange it a little bit, we get negative x squared plus 20x. So to find the x value that gives us a maximum area, let's use the negative b over 2a. So x will be equal to negative b over 2a, the x value for the vertex which contains the maximum area. So we have negative 20 over 2 times a, which is negative 1. So x is equal to negative 20 divided by negative 2 is 10. So if x is 10, then 20 minus x is also 10. So as it turns out, this rectangle is a 10 centimeters by 10 centimeters square. And that will give us a maximum area of 100 square centimeters. Okay, and we have one more problem. A taxi service operates between 2 airports transporting 300 passengers a day. The charge currently is $8. He estimates that he'll lose 20 passengers for each $1 he increases the fare. If the owner is going to increase the fare, what charge would be the most profitable for this service? Alright, so if we have, let's just talk about what we have currently. What's our current revenue? So if we have 300 passengers, and we're getting $8 per passenger right now. That means right now we're earning $2,400. Okay, so we're taking the number of passengers times the cost. So to figure out our formula for increasing the income, let's say I is our income. And we should also define a variable really quickly. So for each dollar he increases the fare, we lose 20 passengers. So let's say that n is the number of times we increase the fare by $1. So here's our income. Currently, we need to figure out passengers times the cost. So currently we have 300 passengers. We estimate that we will lose 20 every single time we increase it by $1. So times the number of increases. So that's our new number of passengers. Times our fare, which currently is $8, and we're trying to figure out how much should we increase it. How many times should we increase this by $1? So if we FOIL this out, we'll get 2,400 plus 300n minus 160n minus 20n squared. So rearrange this and collect our like terms. We get negative 20n squared plus 140n plus 2,400. Okay, so here's this quadratic. We're looking to be the most profitable that we can. So that means we're looking at the vertex and we're trying to figure out how many times do we increase it. So we're solving for n at the vertex. So n at the vertex will be at negative b over 2a. So if b is 140, we'll have negative 140 over 2 times a, which is negative 20. And we'll get 3.5. So it turns out instead of charging $8, we should probably charge $11.50 instead. I got that by taking our 8 and adding 3.5. So our charge of $11.50 would be the most profitable. And as it turns out, he would end up making $2,645 each day, which is a nice increase compared to what he had before. Okay, well that's it. I hope everything made sense, and I will see you later. Bye.